Algebra, no, Algebra 2ers. That's not you. You were once an Algebra 2er. Now you're a pro pre-calcer, but you're still using those Algebra 2 skills here with this new section. P6, dealing with rational expressions. So we've already dealt with expressions. We've seen when we have to plug in for variables and evaluate from there. In the previous section, you saw factoring where box method was introduced, where if we have a trinomial like so, we can take the b term, a times c, have factors here, and rewrite the trinomial so that if we FOILed the factors, it got us back there. So what's different here? We will be seeing that we have a little bit more to specify because some numbers won't work in the domain of these rational expressions. So again, just a rational expression. It's really just a fraction that has some x terms. Maybe it has just 2 terms, but roughly a fraction that can be simplified. And look at that. We'll be simplifying these. We'll be multiplying them, dividing them, adding and subtracting. And I don't know if we see too many complex rational expressions. We'll take it as it comes along. But most of this is going to be relying heavily on factoring. So if you were stuck on factoring, if it's not quite making sense, see if you can go back to the previous section, P5, rewatch that. If you're still stuck, let me know. Or if you need any additional practice, touch base with me in class, and we'll go from there. So we're simplifying. So what does this mean? We can rewrite this rational expression so that after factoring, so kind of the first thing, we'll factor. We can then cancel anything that's repeating. So factor, cancel, and also state restrictions on the domain. On domain from the original expression, which I'll abbreviate to OG. Cool. All right, so the top term, that's definitely something you should know how to factor. That's going to be pretty light. Just y minus 5, y minus 5 again. The bottom term, if you were curious about diamond method for this, you'll notice that there's no x term. So if you wanted to, you could really rewrite this as y squared plus 0x minus 25. This is for the students who prefer diamond method for everything, but terms like these are pretty common to come up, so be open to just rewriting it as a difference of squares. So you should already kind of guess that's a difference of squares, in which case you can rewrite it as y minus 5, y plus 5. So we have in fact factored. Can we cancel anything from the top and the bottom? What do you think? Can we cancel anything? Any repeating terms? You should see that x minus 5 can cancel here and here, leaving us the most simplified expression of y minus 5, y plus 5, and then finally stating restrictions on the domain. So if you recall way back in Algebra 1, you're probably hammered with the idea that you can't have something divide by 0. If you're not convinced, I'll even pull up an example. But what happens? Let's say we have 5 divided by 0. It's not a number, or it is undefined. So eventually when we graph these out, we'll see that that's an issue. We can't have 0 in our denominator. So we state restrictions on the domain to say that this is the simplified expression, but you don't want y equal to a few select numbers. So how does this work? We look at our denominator from the beginning. Even though this canceled, we look at it, and we say that these two terms in the denominator, so y minus 5, that can't be equal to 0, and y plus 5 cannot be equal to 0. And so using a little bit of Algebra 1 skills, we just solve for y. So this would say that after adding 5 to both sides, so these are two little tests, 1, 2, y cannot be equal to 5. So we put that in here. And also if we solve this, y cannot be equal to negative 5. We put that here. So this is our domain restriction. So our final answer, just to reiterate, this is the important stuff. This is definitely the final answer, but you also want to state this kind of to back yourself up and say, oh, well, I know it can't be equal there because it would be undefined, and this is definitely not an undefined expression. So this covers your ground. So let's see what happens when we multiply or divide. Definitely intimidating, but stay with me. Trust me, you'll get through this. So what can we do? When we're multiplying, we will just multiply across, and we'll eventually get to the operations. But first step, I like the steps. This makes me more at ease. So we can just factor what we can. We'll then flip fractions being divided. This is a really important step because if fractions are being divided, we need to take the reciprocal, and we'll get there in a second. We can then cancel anything. Then we'll state our domain. All right, so this is going to be a lot of factoring. If you have any questions, pause or take some time. Maybe you can factor most of this. I think you can. So try it out if you want to. So I know the top here is the difference of squares, x plus 3, x minus 3, over x plus 9, x minus 2, up here x minus 2, x plus 1. This is x plus 3, x plus 4. We then can do a little bit more here. Factor out x. We get x minus 3. Finally, x plus 9, x... Oh, no, pump the brakes. This can be... What can this be? Help me with this factoring. Psych, it actually can be x plus 9, x plus 4. All right, cool. So we factored everything. We were kind of lucky here. We had a pretty clean sweep. We could do that. We can then flip fractions being divided. So this second fraction, I'm just going to rewrite it, but now it's flipped. Because whenever we divide with fractions, we take the reciprocal and then just multiply across. So let's do that. Now we're multiplying. I'm going to keep the first two rational expressions the same. X plus 4. Lot to write here, but don't get lazy. You got it. All right, cool. So we've flipped everything. Is there anything we can cancel? This is the fun part. Look for a pattern. All right, what can cancel? X plus 3, x plus 3, x minus 3, x minus 3, x plus 4, x plus 4, x minus 2, x minus 2, x plus 9, x plus 9. All right, what's left over? We just have this x plus 1 over x. So that's left over. Seen here, there's nothing else. For the domain, we'll say that x cannot be equal to, if you want to set up equations for all of these, go for it, but you can say x cannot be equal to -9, +2, -3, -4. I already got -9, -4. This can also allow x cannot be equal to 0, so be mindful of this. X cannot be equal to 0 or 3. Cool. So that's our domain. Pretty hectic. And yeah, there is a lot going on, but take your time.